Hi everyone. So in last session we discussed about what is BI and data warehouse, and we discussed about how data will be processed from different source system to data warehouse and the reporting layers, and the advantage of this business intelligence and how we are going to use this with data warehouse. So I hope you are clear with all these things. And even we discussed about what is MSBI and what is Power BI and how what is the differences between these two and how we are going to use this. And we discussed about what is OLAP, OLTP, and the difference between these. And also we discussed what is database and data warehouse and their differences. So I hope you are all clear on these topics since we covered very less with more explanation, with more examples. Okay, so we'll continue with the same topics like in the data warehouse. What we have another topics like what are the fact and dimension, and what are the different schemas we have, and what type of keys we have. So we'll see all those things. Yeah, I'll try to complete this BI and data warehouse concepts today, and we'll start SQL later. Okay, so you need to understand what is data warehouse, data marts, and operational data stores. So as we discussed about data warehouse, you have a clarity on this, but you need to understand what is data mart and what is operational data store. We'll see one after one, which can avoid confusions. Okay, so a data warehouse is also known as enterprise data warehouse. Enterprise data warehouse means it's organizational level data warehouse or company level data warehouse. It's a system used for reporting and data analysis and considered a core component of business intelligence. Yes, it's a part of business intelligence, and this
ఆ
use.
ఆ
Guys, please be on mute
చెప్పే
yourself.
చెప్తా
Guys, don't disturb the session. Please be on mute
ముందు
yourself.
చూస్తా.
Even other participant can mute others. Okay, I still heard some noise. Okay, still I'm getting noise.
I think we are not able to unmute them, right? I'm trying, but it's not working.
Okay, let me mute. Let me pause recording here. I'll see. Okay, so yeah, so we are discussing about data warehouse again, and so this data warehouse we also known as enterprise data warehouse, and we use this for reporting and business analysis purpose, and we can say this is a core component of our business intelligence. And what it will do is, or how it works as, it is a central repository where data can be integrated from one or more systems. We already discussed with different examples in the OLAP and OLTP concepts. So from OLTP, we'll be getting data from different source systems. Then we are processing this with the SSIS process, and we are integrating this data into a central repository, also known as data warehouse. Okay. And what is data mart here then? So our data warehouse will have complete data of our business. It may be related to HR information or product information, finance information, or any service information. or if you have any production, even it stores production data also. So if you have all this data into a single system, but if you want to call or if you want to read data in the reporting layer, then you should have segregate, you need to segregate this data into different categories like HR related data into one segment and finance related data into one segment, or product related or sales related, anything. So you are segregating these data. So these segregation we can call as a data marts, or in technical terms, we can say it's a logical subset of our complete data warehouse. So the related information we are storing into a particular location or into a particular logical subset. Okay. And what is operational data store? So this is similar to OLTP. Okay, we'll see that. An operational data store is used for operational reporting and a source of data for the enterprise data warehouse. Yes. So as we said, from OLTP, we'll be having multiple data sources, and it process data into integration process, then it stores data into the data warehouse. So for this data warehouse, we can call sources OLTPs, and that OLTPs are operational data stores. Okay, so then with this, we can say for data warehouse, we have a source system called ODS, operational data stores. Okay. An operational data store is a database designed to integrate data from multiple source for an additional operations on the data for reporting, control, and operational decision support. So this entire process will help to understand the business, and it helps to take decisions for the business users. So it is all sentences are repeating, but we are using different terminologies. You should be familiar with all these things. Okay. So then, as we know, this all OLTPs has daily updates when compared to OLAP. So OLAP has batch updates. So you can understand with this ODS supports day-to-day operations, and it needs to be continuously updates. Okay, so let me summarize this. What is data warehouse, data mart, and operational data stores? I'll explain the relations. So operational data stores will process data to the data warehouse. Once we have data in data warehouses, we'll be creating logical subsets depends on business data. Like business have different category information like employees information, like it comes under HR, and sales information it's up, or investment information it comes under finance. And even if you want to segregate that finance information into multiple sectors, even you can do that, investments and sales, like this. Okay, and even we'll be having inventory data also, demand data also. But if I use inventory and demand, it'll get some confusion. So that's why I'm using general words which you are familiar. Okay. So the flow of this will be getting data from operational data stores, and we are integrating that into data warehouse. From there, we are creating data marts. Okay. Then we discussed multiple times we are transforming data from one like source system to the destination. So what this transformation includes, we'll see. So this transformation includes extract, data extraction, conditioning, matching, loading, validating, and delta updating or incremental loading. We'll see all those things, what we are going to with each and every step. Extracting. We'll be extracting data from different source systems that we already discussed. So once you extract data, we'll not processing as it is to the destination system. So we'll apply some conditions, like maybe we'll be aggregating data. Like for example, from uh, same person, there will be number of business transactions. So then you can aggregate that and will be showing as a total, like it may be max, minimum, or total. So like how we can conditioning, but it is not only that, it is one of our example under the conditional process. Okay, then we'll be matching data. So like we'll be having different tables or different views, but we are using merging concept to combine all into a single. Okay, and load data. So once we do all these things, we'll be loading this data into our destinations system, then we'll be validating. So once validation involves like we'll be comparing data in our destination system and source system. If it is matching perfectly, then we are good to go for next step. If there is any mismatches, then you need to debug these things, like where we have a disconnect and why it is not matching. So these steps we are going to do with that validation process. Okay, once we validate, it depends on the business process or business volume. We'll be loading data into the source system with the different ways, like we'll be loading entire data or we'll be loading only incremental data. I'll explain the difference between these. Loading entire data involves, like if you have a history of 1 month data, then if you are loading again, you'll be loading complete 1 month. But actually, we'll be getting latest records for yesterday or today. But the data will not be changing for last week or before that week. Since it is already done, there is no changes will be happened for the historical data. But still, if you are loading entire data, since you are making this 1 month as an interval. Okay, so to avoid loading all history data, we'll be using incremental loads, which helps to load latest data only. Like if you want to load only uh, last 3 days of latest data or last 1 day of latest data, then we use this incremental load policies. Let me summarize this incremental load. So incremental load, which helps to load only latest data. So it helps our time and it helps our workloads. Okay, so loading historical like 1 month data, 1 year data, loading 1 day or 2 3 days data, you can just assume your business has 1 crore of records, and for day-to-day transaction you hardly have in thousands. Loading 1 crore and loading 1,000 data, it's a huge difference. So here you can save your time and you can save your cost. Okay, we'll see that. But if we have a less volume of data, then we don't consider about this incremental loading. But if we have a large volume of data, then we'll be consider this incremental load. Okay, so data transformation terms, including this extracting, conditional matching, loading, validating, and incremental load or delta loading. Okay, if you have any questions about or confusions about this data warehouse, data marts, and operational data stores or data transformation terms, you can ask. I'll give some time here, or you can ping me. Okay. If no doubts, we'll move to next topic, like what are the dimension tables and fact tables, how it designed. We'll see this. So we'll take first dimension tables. So what is dimension table and what are the examples? So dimension table is a collection of related fields or columns and make it as a table. Yes. So we have let's say an example, dimension date, dimension zero region or dimension zero table, or dimension product or dimension customer. Okay. So if you see here, of we have one table for date and we have it one table for location, or we can say zero region, or we have one separate table for product. So why do we have a separate table for all these things? Just to show their related information. Let's consider customer table, an example for this. Like customer table can consist only customer information, like customer first name, middle name, last name, customer contact number, or customer email ID, or anything related to only customer. So this table will not include any other information like product information, like what type of product he purchased and from which location he purchased and from for which date he purchased. So all this information will not be there in the customer table. Okay. So that's what it is saying. It is a collection of related fields or columns and make it as a table. So it has only customer information. So if you consider product table, it has only product information like product ID, product name, product color, product weight, or product name may be from different regions like different countries. Okay, so it has only product information. When it comes to location table, it has only location information like location ID, location country or location state, location city, our address line 1 or at least line 2 or landmarks. So these kind of information will have location table, or we can say geo region table. Okay, it depends on your business justifications. And date table will has only date related information like full date, a short date, a month name, month number, year number. Like how we have multiple column, we'll be having multiple columns, and on top of this even we can create a few more columns as per our business requirements that we'll learn once we start Power BI. So I hope you understand this first point clearly. It's a collection of related fields or columns to make it as a table. Okay, so these are the different examples and what other points we need to remember. So define business in terms already familiar to users and wide rows with lists, lots of descriptive text, small tables, about million rows. It's all about your business transactions and joint fact table heavily indexed. Let me summarize. So, and one more point to be included here. Every dimension has a primary key. We'll discuss later what is primary key here. And this, as it is a dimension table, it needs to show complete information about your particular dimension. Like if it is a customer, then it's supposed to have a customer name. So then it will be a text. And for example, even if you want to show an email contact, even it will be a text. So like how we have some text information in our dimension tables, and what it will do is it will connect to the fact table. Why we need to connect is, for example, if we have only customer table information in a single table, if you want to get information like some XYZ person, I want to know how many product he purchased and what is the total sales we got from him. So if you want to know that, you cannot find, since you'll not be having this data into a customer table. What is that data? Sales data. So then how can you get that? So you need to connect to the other table called fact table where you have sales information. So that's why this dimension tables will be connecting to the fact tables to get this business transactions or to get the sales or conversions. So it's all depends on domain we are working. So if you are working sales domain or like e-commerce, then we'll be using sales terminologies. Or if you are working with any production, like any manufacturing things, then we'll be using different terminologies. Okay, fine. So, and it is heavily indexed. Yes, we'll be having two type of different indexes in our SQL server. I'll explain that what is index and what how it works. But you just remember dimension tables are heavily indexed and yes, so
Yeah, you're telling that it's joined to the fact tables, right? Fact tables, yeah, I have a doubt here is what is the fact table
yeah,
particularly? Related to which information,
I'll
which
explain.
data it's stored in the fact table.
Yeah, I'll explain. So we are just discussing about dimension tables now. So of once we finish this dimension table in explanation, then I'll go to the fact table. It
Yeah,
will
okay.
be next. Okay, fine. Okay, so just remember here, we are discussing only dimension tables now. So once we complete with the dimension table explanation, then we'll go to the fact table. Then you'll be getting more clarity on this. So first, remember few points about dimension tables. So this dimension tables will have only related fields or related columns into a table. That is one thing. And each dimension table have a primary key, and it will have some descriptive text information, and compared to fact table will be having less number of records, and this dimension table will connect to the fact table, and it has heavily indexed, which helps to uh, get data very faster. Like it helps to retrieve data very quickly. Like when you are interacting with databases, if it has indexed, then it helps to get data fast. If you don't have indexes, then it will take time to read this query data from our databases and retrieve in your results or populate in your results. Okay, so I explained like more points, but just remember main thing, dimension table will have related fields or columns in a table, and it has less number of rows compared to fact table, and it has a primary key. And few examples are dim customer or dim location or dim geography, dim product, dim date. So you can give these examples. I just given overview on this. Then we'll move to the fact table. Yeah. So fact table is a central table, or we can say a centralized fact table is connected to all different dimension tables. And remember one thing, yeah, I'll explain that in schemas when we are discussing about this to avoid confusions. And so this fact table has individual sales records, mostly raw numeric items, and narrow rows, a few columns at most, large number of rows, access via dimensions. First thing, this fact tables will have raw numeric information, like we can say all numbers information, since it has all business transactions. Like we'll be having sales or margins, profits, discounts, all this information will be having in fact table. Along with this, to connect with the dimensions, we'll be having key columns like customer keys, location keys or geography keys, product keys. So these key information will be having in the fact table. I'll show with examples. I'll open a database and I'll show how dimension table has been designed and fact table has been designed. So to give an explanation about fact table, we can say this fact table will connect to the dimension tables, or we can call this as a centralized table. And this fact table will have all raw numeric information, and you can give an example like sales information or margins, profits, discounts, and this fact table will store as a new record for each and every business transaction. Like if you purchased one product from your through online, it just add one record into the fact table, or you purchased same product n number of products, like you purchase 10 pieces for the same product, but still it will add 10 rows since you purchased 10 products. Okay, so like how it stores data for each individual transaction. Like if you purchase 10, it will store 10. If you purchase 100, it will store 10. Even if it is the same customer or same product, it doesn't matter. So like how we'll be having number of records, more number of records, like millions to billions, even more than that. But when it comes to the dimension table, just assume you are a customer, you purchased 100 products, but still this customer table will store only one time, one repetition will be having, you will be having only one row for entire this table. Then as you purchased a product, like same product 100 times, even the product name will not, our product will not repeat 100 times in our product table. It just stores only one record since you purchased only one product, but you've taken 100 pieces. So like we'll be having only one record when compared to the dimension, when you see in the dimension table. But when it comes to the fact table, as you purchased 100 items, you'll be getting 100 transaction rows. Okay. Even if it is the same customer or same product, doesn't matter. As you purchase 100, it will give 100 rows. So like how we'll be having large number of rows in our fact table. So if you have any doubts now with the fact and dimension, you can ask. So to give more clarification, let me open our SQL Server Management Studio and I'll show you how data will be integrated in fact table and dimension table. Okay, until it open, if you have any doubts, you can ask between fact and dimension.
It's fact table means it's all numeric related information only, right? Raw
Ye-
numeric related information. It's not related to data like names, nothing like that. It's all
Yes,
related to numeric on.
yes, you are correct.
In dimension, we'll get all the information, right?
Yeah, in dimension we'll be
Like
having
names.
text, yeah, names. Even in dimension we'll be having numeric data too, but since as it has separate category, we do require to add some text information like product name, customer name, location name and all. But we still have some key information also, like in customer table, we'll have customer contact number, it is in digits, and a customer key. The key information, it depends on business how they are justifying, like 1 2 3, or it may be 1 A 2 B, like this. So for example, just consider your ID card from your company or from your college. This ID card, few organizations will display like 1 2 3 4, but few organizations will display with some mixed test like 1 A 3 4.
Alpha numeric, yeah.
Yeah. So like how, yeah, I hope it open. Let me show you. I'll explain you how to install this SQL Server Management Studio and how to create this databases and how to create tables and all. I'll explain, but just want to show you how dimension tables and integrate, or how fact tables are integrated and what kind of information it has. I'll show you here. So So we have a data warehouse like AdventureWorks DW 2022. Under this, we have a tables. We'll see what are the tables we have. So we will be having dimension tables and fact tables. If you see, few table name starts with dim, few tables will start with fact. So with the naming convention, you can understand this is a fact table or there's a dimension table. It's all depends on your naming conventions. Okay. So let's consider dim product as we discussed in our examples. So to call it this table, we need to write a small query start from table name. Table name is dim product. So just run to see the data. So if you see this dimension, product dimension table, we'll be having product key and product alternative key, subcategory key, and weight unit measure code, size unit measure code. So it's all product related information. Even you can see English product name or Spanish product name. So they mention only product related information, whether it may be product key or product alternative key or product name. Even for the name will be from different countries or different regions, and product color, safety stock level, period. So if you see these columns, this all related to product only. Here you cannot see customer information or location information or sales information in this table. So this table you can see only product information. Okay. So like how our dimension tables will have, and if you see here, we can cover one more point. As I said, we'll be having text information and number information too in the product tables. And indexes and all, I'll show you later when the topic comes. But just understand this product table, uh, this dimension table will have only their related information, and it has descriptive text information along with the numbers. Okay, and if you see here, we'll be having less number of records. If you see this product, we have only 606. So since you have only these many products for your business, so these all example. Okay, if your business having more products in thousands or lakhs, even you can see those rows here. Okay, so 606 rows, generally we can say less number of records or less number of rows. So let's check one fact table. Fact, fact internet sense. Let me show you this. So this is one of our fact table from our data warehouse. So here, if you see here, we'll be having product key information, order date key information, and currency key information. And if you see, we'll be having some other keys information. I'll explain you why do we require this in the fact table. And you'll be having unit price, order quantity, how many orders you got for this, like whether it is 10 orders or one order, and extended amount. Yeah, so this all related sales transaction. Okay, sales amount, total product cost, tax amount, and discount amount, unit price, discount, PCD, some other terminals. It's all depends on business. So these column naming convention will be defined by the architecture or business owners. Just but what you need to understand here. So what fact table consists? What type of information we can see in the fact table, and what information can be stored, and so these things you need to understand here. So fact table will consist numeric items or numeric information, and it has business transaction information. Like if it is a retail industry, you'll be having sales information and units purchased or units, yeah, and discount amount, tax amount, profit amount. So these information will be having. Okay, and let's comes to this keys. So what is the purpose of using this keys in the fact table? As we said, our dimension tables will connect to the fact tables, and fact table will be connecting to the dimension tables. Okay, so to connect one table with another table, we should require these keys. Okay, so these keys will help to join a table with another table. So this will understand when we start our keys concept. Okay, but here what you need to understand, what is fact table and what is dimension table, how it is defined. So just understand this much, so then we'll see keys or constraints in future sessions. Okay, so as we've seen here, dimension table is a collection of related columns or fields and make it as a table, and define business in terms of already familiar to users. It is not much for what the point, but for the users, it really helpful to read data if we store this organizing way, in this organizing way. Okay, and wide rows with lots of descriptive text. Yes, will we, as we have seen, dimension table will have text information like to display customer names or product names or location names. And compared to the fact table, dimension tables will be less volume rows, will has less volume rows. So dimension tables, when we have seen product table, we noticed it has 606 rows, but when it comes to the fact table, it is having 60,000 rows. Okay, so why we are having more in the fact table? We'll be having like we'll be having more records since every business transaction will be adding as a row in the fact table. Okay. So if we discuss too much, then it will be there is a possibility to get confused, but just understand what is the main difference between fact and dimension. Okay. So let me summarize. See why I'm spending more time on this is this is a standard interview question. So what can you explain what is fact table and dimension table and how it relates? Or they can ask difference. Can you differentiate what is fact and dimension? Okay. So let me summarize here. Dimension table is a collection of related information and making, or we can say it is a collection of related information and storing it in a single separate table, or we can use this standard definition like is a collection of related fields, columns, and make it as a table. It will be having less number of rows compared to the fact tables, and will be having respective text information in dimension tables, and this dimension tables has heavily indexed and it connects to the fact table. Few examples for dimension tables are customer dim customer or dimension customer or dim product, dim location, or dim date. And when it comes to the fact table, we can say it's a centralized table. It will connect to the dimension tables, and this fact tables will be having foreign keys. This is one more point which is most important. And if you say this, then even interviewer will think so. You have clear knowledge about what is fact and dimension and keys also. I forgot to mention this here. Dimension tables will be having primary keys, but fact tables will be having foreign keys. I'll explain what is primary key and foreign key later, but just remember this. And fact tables will be having large number of rows since every business transaction will be adding as a new record. Okay, so these points are enough. Even if you learn more or if you want to explain more, you can do that. Okay, so next we'll see what type of schemas we have in our data warehousing concepts. Okay, so first we'll see what are the schema types. Like we will be having mainly we use two type of schemas, but we do have other also like star schema and hybrid schema, snowflake schema. But in general, we use star schema and snowflake schema only. Okay, we'll see that. So if you see here with diagram, you can easily understand how star schema is designed or how it works. A centralized fact table is directly connected to all dimension tables in your model. Okay. See, centralized fact table is directly connecting to all other dimension tables. If you see here, this time table or customer table, product table, city table, everything is directly connected to the fact table. There is no bridge table or there is no other table which is helping to connect to the fact table. Okay. But if it comes to the Snowflake schema, here a centralized fact table may not be connected directly to all other dimension tables. There is a possibility or there will be a bridge table which helps to connect fact to a dimension. If you see here, this region table is not directly connecting to the fact table, but it has a connection. But it is an indirect connection, but it has a connection. So it is taking city table. City table helps to connect to the fact table. So these kind of schemas we can say snowflake schema. See, star schema. What is star schema? A centralized fact table is directly connected to all dimension tables. So this we can say star schema or A centralized fact table is directly connected to all other dimension tables. This is known as star schema. And when it comes to Snowflake schema, a centralized fact table may not be connected to all dimension tables directly. There will be a bridge table between one dimension to a fact table. Okay, so just understand this. Okay, so this is about star schema and Snowflake schema. So we can see once we start our SQL sessions in practical, and you can understand the importance of connecting tables once we start this SQL topic, since we will be working on different tables. Okay, as I said, we'll be having some keys, and we'll see few of data warehouse keys, and understand the purpose of keys and how it works. Okay, so first understand what is a key in data warehouse. A key is one or more data attributes that uniquely identify an entity. Yeah, let me give more explanation to understand this. So this key will help to understand, like, for example, if you consider a row which is having customer information, like for example, if you see with this name, even in your organization or in your school, with the same name, there will be multiple persons. But to identify uniqueness, what we'll be using? We'll be using a roll number or any other extensions, like with initials. Maybe the first name will be similar or last name will be similar, but they'll be having different surnames. But in few cases, there is a possibility to get surname also similar. So in this case, we'll use keys like student ID numbers or employee ID numbers. So like how we'll be having key is one or more attributes that uniquely identify an entity. Okay. And natural key. Natural key that is formed of attributes that already exist in the real world. For example, US citizens are issued a social security number. So let's take our Indian example. Natural key. As I said, a person can have, like, a name will be, the single name can be there for multiple persons, but if you consider Aadhaar number or voter ID or passport number or DL numbers will be unique for each and every candidate. So this is not a business data, but it is a general data for humans. So like how we do have SSN for US citizens. So why we are mentioning this, that is a separate topic, but just understand what is natural key. A key that is formed of attributes that already exist in the real world. It is not a business data, it is already exist in the real world. Okay, but which will be an unique identity, which will be an unique, which will consist unique value. Okay, so my Aadhaar number will not be duplicate for others, or my voter ID will not be duplicate for others. Okay, just remember that. So but it doesn't have any business information, it exists in the real world. Okay, so then surrogate key. So surrogate key with no business meaning, and it is generated by the system. Let me give an example. Like, you'll be creating a table, and if you want to create an extra column to show your data in unique way, then we'll be creating with our queries or with our system. So that's called surrogate key. We do have a concept, same concept in our SQL. So there we'll call it as identity key or identity column, which will help to give uniqueness of our entity, but that key will not have any business meaning since it is not coming from our business, just we are generating for our uh, business or BI reports part, like to develop a reports or to create a models. This key will be helpful, or even this key will use in joins concept that will be that we'll discuss in next part. But just understand what is surrogate here. So this key doesn't have any business meaning. It is just generated by the system or a query. So, but even you can give it is similar to identity key or identity column. Okay, identity key or identity column we'll discuss in SQL. But here, what you need to understand, just surrogate key doesn't have any business meaning, but it just generated by the system. The advantages that we'll discuss once we start our querying part in SQL. Okay, candidate key, it's a combination of name and phone number. Why we are combining this? If you consider only customer name, you cannot find completely unique when compared to with other customer information if you consider only name. But if you consider phone number, each and every customer will be having unique numbers. So if you combine this, then you can find the uniqueness. So that's why we'll be combining this. Yeah, we'll be combining. So this candidate key, also known as composite key. What composite key will do is that key is composed of two or more attributes to get an uniqueness. Okay, so candidate key is a combination of name and phone number. And this is also known as composite key since we are composed to our more attributes. And what is primary key? Preferred a key for an entity type, but we do have some other standard exam definition. A primary key can have unique values and it doesn't allow single null value. Okay, that we'll discuss in our constraints topic in SQL, but understand this. It's a preferred key for an entity type. Each and every dimension will have a primary key. Okay. Alternative key, it's also known as secondary key, is another unique identifier of a row within a table. So all these keys will be helping to show uniqueness. Okay. And foreign key. So foreign key, one or more attributes in entity type that represents a key either primary or secondary in another entity type. So let me give some simple definition. So this foreign key, what it will do is it will connect a primary key from another table. It is a simple. Even this sentence also will give same. So all this, so except this foreign key, all these keys will be helping to get a uniqueness. Okay, so let me summarize. Key is one or more data attributes that uniquely identify an entity. So this is also showing uniqueness. And natural key, it doesn't have any business meaning. It is a part of our real world. So example, Aadhaar number, voter ID number, or any other numbers. Okay. And surrogate key, it doesn't have any business meaning, but it's generated by the system. Okay. And candidate key, combination of name and phone number. So when you compare this two, or when you combine this two, you'll get a unique record. Okay, so this is also known as composite key. What key will do is it composes two or more attributes to get an uniqueness. And primary key, it's a preferred key for an entity type. So each and every dimension will have their own primary key. Okay. And alternative key. What is alternative key? It's a, we can say, secondary key for this in the same table, which will help, or which is another unique identifier of a row within a table. And foreign key, which is connecting to a primary key from another table. See, if you try to understand everything at a single shot, it will be little confusing. But when you start repeating this, then you'll be familiar with this. Okay. So we covered what is dimension table and fact tables and star schema and snowflake schema and data warehousing keys. And even we discussed operational data source, data marts and data warehouse. Let me complete this software development life cycle. It's a general topic which you need to understand as you are joining in as you are joining with some experience. You should know all these things. Even if you are a fresher, it really helpful and it will give more weightage when you answer perfectly to the interviewers. Okay, so what is SDLC? Software Development Lifecycle. So what steps involved in this software development lifecycle? It is not only for our business intelligence. Even if we consider any other development activities, we follow the same procedure. So first, what we do is we gather the requirements from users. Users means our clients, or okay, business users or our clients. So once you know what actually they want or what actually they need, then you can deliver the same kind of reports or same kind of product. Okay, so first step involves gathering the requirements and doing analysis and all. Okay, so the steps involves mostly we do interact with the clients to get as much as possible information what actually they are looking, and then we define that to start our processing. So like what we have to do to reach users expectations, so where we need to start and where we need to end, what we actually need to complete this developments or to complete this deliverables. Okay, so once you define, then you start designing it. Maybe we use different tools or different applications to complete this user expectations, but all that we'll define and then we'll design that. So once you have it designed completely, like here architects involved to design this. Okay, so first to get information, our business analysts, our BOs, business operations, so they'll be involving to get to interact with the users. Even they'll involve you as a developer to understand the challenges and defining so their understandings from the customer. So they define how we need to start and where we need to end. Then the design complete uh, project, so which where we need to start and what we need to use and all. So they start implementing through codings and all. So if it require, like if you see to create data warehouse or to create a databases, we do use SQL. So those queries we do here, and then we'll test it how it is working. Are we getting expected results or is there any disconnect? So these kind of testing will be done in the testing. So if you find any disconnect here, then we'll be sending this back to coding or developers so they can fix that. Then they send us to again testing layer. So if it is success, then we'll deploy these changes to a prod environment. So if users are sign off with this, then we'll go for the maintenance. Okay, first we'll be interacting with the users to understand their requirements, and then we define their complete business. So then once we have clarity on that, then we'll be designing our workflows. Okay, which tool we need to use, or what are the complex challenges we are going to face once we start this project, and what is the manpower they do require, and what type of tools and their licenses and all they'll be designing in this layer. So once it is done, then we'll start implementing through codings if it is related to coding. Okay, once they done this, then they'll send it to testing. So if everything goes well, then they'll apply these changes to production. So then users will come and see here if they are sign off, like if they agree with this, like if they feel it is how it is how they are expecting, then they'll give sign off. Then it will go for the maintenance. Like once we done this development, there will be maintenance also. So that's why we'll be maintaining this. So it depends on your project or depends on your business domain. There will be few steps involved or maybe one or two get out, but this is a general standard software development life cycle. So gathering requirement, defining, designing, coding, testing, and deploying to the prod environments and maintaining. So this is a general topic, but which is required to know. So I'll conclude with this slide. So even this is also general, but why I added this, you should know this if you want to join a BI developer. Okay. So as we discussed, the same points will be repeating here, but you'll be understanding where your work will start actually, or if you're stuck somewhere, whom you need to reach. Like as you are going to work as a report engineer or BI developer, you need to know um, you need to know the complete project life cycle, and if you're stuck somewhere, you need to understand which team you need to contact. Okay, so that's that. So to get this information, this slide will help. So as I said, we'll be having first client. Okay, so if we have a client, then we'll be having a project. So to interact with the client, we'll be having business analysts. So they'll be interacting with the clients and they'll get all the user requirements. So then they'll pass this information to the architects. So who is architects? The person who can design complete architect of data warehouse for any business. So since we are discussing about a business intelligence concept, so that's why we are using our standard word terminologies like data warehousing and all. But in general, we didn't use this data warehouse here. Okay. Okay. So the BI architect will design complete architect of our data warehousing for any business. Then who next comes as team lead or consultant or module. Okay, so what they'll do is, what can they handle is, so they can handle ETL developers or cube developers or OLAPs, even you can say semantic models with the latest terminology, or dataset developers, okay, and report developers. So these team leads or consultants, they can handle till the BA developer role, but they'll not be working all these things. They'll lead the team. Okay, so first you'll be joining as a report developer or BI developer. What you can do is you'll be creating Power BI reports or PageNet reports through report builder. Okay, so this is where your role will start. But if you are good with this queries, then even there is a possibility to include you in semantic model development or database development activities. Okay. So first, let's see flow, then we'll discuss later. I'll summarize this. So after this, team leaders. So what we'll be having ETL developers. Uh, what they will do is they'll integrate data from different source system to a centralized system. So this process we already said, integration service, or we can say SQL Server integration service. Okay, then Cube developer or OLAP developer, the person who works on SSAS, cubes creation, and MDX language. See here, before we were using all these concepts, but as our Power BI releasing monthly updates, we have an wonderful updates. So that's why we are not using these cubes now, but still we are using, but very rare. But we are using here is semantic models. Semantic models we are using. So that is also known as data sets that we can learn once we start Power BI. Okay, so report developer. What report developer will do is they develop the reports. It may be in Power BI or it may be in any other BI tools like Tableau or Cognos or QuickView or Oracle BI. So report developer will do just reporting. So as we are learning here Power BI, we do Power BI reports, and also if user is expecting paginated reports, we just use Power BI report builder, which helps to create a paginated reports. We do have SSRS, but it is completely on-prem. Most of the users, they are not using this. But SSRS and report builder are similar. So report builder is an advanced version of SSRS. Okay. So next, BA, if your role is BA developer, then you'll be doing all these things, ETL activities, dataset buildings, and report buildings. Okay. So I'm expecting you should be there in this position. Okay. Don't stick on only report developer. So if you learn this SQL, then you can cover all these things. Okay. Fine. So next, what once you complete this report development activities, what will happen? So you need to share this reports to the users. Users means the clients, okay, or who can take actions on business. Okay, so how you'll be sharing? You'll be using Power BI service, then you'll be sharing these reports through workspaces or by creating automated setups through Power Automates. So there are different steps involved to share this reports to the users. So, but to handle this, to do means sharing with the reports, sharing this reports to the users, uh, it's okay. But if you don't limit the permissions, there is a possibilities to manipulate this reports too. So to limit the permissions, you need to know administrator activities or you need to know admin activities. Okay, it is not a tough challenge. It is simple. It doesn't involve any coding. It's all mouse operating system. Okay, so few companies they will not allow you to handle this admin activities. They'll be having separate team. So if you don't have a separate team, even you can handle this. Okay, we can just limit users with a just viewer access. You will not allowing user to go with the edit access. If you if you allow clients to use with the user access, they can view a report, but they cannot manipulate. They cannot change anything. Okay. So these roles comes, so this work comes under admin part. So if you are strong, then from this team lead position, you can handle all these things. Once you learn everything and once you gain some practical work experience, then your target will be BA architect. Okay. So this is not that much simple, but you should be strong on all these environments. Then you'll become BA architect. Okay. Okay. First focus on BI developer. Why I'm telling this BI developer, since I'm training and I'm going to train you for this all only. So along with the reporting activities, I'm giving a knowledge on you with the queries part also. Okay, so understand the difference and understand the flow. So for example, you're working as a report developer and you have some issues with the data. Like just consider if you have a large team and that workflow is not allowing you to do all this, like you're not going to create a semantic model or you're not going to work on any database activities. Your part just involves only a reporting layer, then you find an issue here. So then whom you need to reach? You need to reach dataset owner or model owner. Then you have to show, so this is the disconnect I'm seeing. So can you find where it went wrong or can you allow me to investigate? Okay, so here you should know your point of contact. Okay, if you struck here, then you need to contact to this model developers. So if model developer didn't find this issue, like if it is not part of this layer, then he has to go to this ETL developer. Okay, so like how you need to understand the dependencies. Okay, so that's why we include the slider. Okay. Without knowing dependencies, you find an issue, but you don't know whom to contact. Then it will be a problem. You need to reach others and you need to get some information. So if you do all these things, still you will be dependent candidate. So my expectation is you should not like, you should not be a dependent candidate. You will be an independent in your work environment. Okay. So understand this. And if you still have any confusions about this roles our software development life cycle. Not only this, even if you have any questions today's session or even in the last session, you can ask.
Mind as of now, no doubts.
Okay,
Thank you.
thank you. Let's stop recording then.